Hello everyone. Good morning, good afternoon, good evening to all. Welcome to the technical session 4C. I am Riddhi Gohil, moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome the 6th World Conference on Smart Trend in System Security and Sustainability through Zoom. I hope you will all enjoy the knowledgeable interactive sessions of the day. Just before we get started, there is one special note for all authors. You will be given 12 minutes for the presentation and the 3 minutes for the question answer. And on 10 minutes, I will raise a gentle reminder to conclude our presentation. So please be stick to the time limit. There is another request to all. Please stay connected with us until the closing remarks. There is another. So just before we get started, I would like to introduce to all our chair of the session, Professor Durgesh Kumar Mishra and Professor Milan Juba. So sir, I welcome to you, sir. Sir, I would like to introduce.
Thank you.
Yes, sir. I would like to introduce small introduction about Durgesh Kumar Mishra sir and Milan Juba sir. So Professor Durgesh Kumar Mishra has been working as a professor and director in Microsoft Innovation Center at Sri Aurobindo Institute of Technology, Indore. He has a 24 years of teaching experience and 10 years of research experience. He has published more than 90 papers in referred international national journals and conferences, including IEEE SEM conference. He has organized many such conferences like WOCN in the capacity of conference general chair and editor of conference first. And our Milan Chuba sir is currently a vice rector of Singing Dam University, Serbia. His research interest includes mathematical twin theory and heuristic optimization applied to computer networks, image processing, and combinatorial problems. He is the author of more than 150 scientific papers and monographs. He is also co-editor and member of the editorial board, scientific committee member, and reviewer of several international journals and conferences. Yes,
Thank you for the introduction.
Yes, sir. So, can we start our session, sir?
Yeah, you can start.
Yes. So I would like
to... is also there, and we can start.
Yes, I would like to invite our first presenter. Our first presenter is Shamil, and paper title is Digital Platform for Monitoring and Comprehension of Children with Autism Spectrum Disorders.
Hello, everybody. Do you hear me well?
Yes.
Okay. Let me share my screen.
Yes, sir.
Dear friends, do you see it?
Yes, sir. It is visible. Can you please make full screen, sir?
Okay. Okay, is it okay?
Yes, it is okay, sir. Right.
So I'm starting. My name is Shamil Shrimardanov. Good day, good morning, good evening to everybody. I'm a deputy director of the Institute of Psychology and Education of Kazan Federal University in Russia. I would like to introduce my colleagues and authors of this research who are joining us at the meeting. Dr. Irina Nigmatulina, Associate Professor and our university's kindergarten scientific director. She is sitting with me here. and Dr. Mikhail Abramsky, Associate Professor, Director of the IT Institute of our university. So we are proud to present the Kazan Federal University located in Kazan, the capital of Republic of Tatarstan in the heart of Russia. Our institute provides professional development for teachers and professionals working with children with special needs, including autism. Kazan Federal University is just at the beginning of its research into autism. Autism spectrum disorders are currently the focus of 2 research labs at our university. One devoted to psychological and pedagogical research and another to medical, psychological, and linguistic approach. We provide both education and research in the field of autism, both in the form of training for the next generation of educators and practitioners, and also scientific research projects. And today I'll speak mostly representing psychologists and educators' side. In order to provide comprehensive support to children and their families, we try to cover as many aspects of child development as possible. Among our research areas are education conditions and in preschools, children socialization, neuropsychological studies, regulatory functions, school preparation of preschoolers, relations between children and parents, and teachers and doctors support in practice. First of all, I'd like to introduce our university's kindergarten for children with autism spectrum disorders. It can now accommodate a total of 120 autistic kids. At the same time, it's a good area for psychologists, educators, physicians, physiologists, neuropsychologists, and others to share innovative methods and conduct their research. Our university team has built a digital platform for gathering and evaluating data on ASD children's support, which we hope will find interesting. This platform serves as a resource for researchers as well as educators, assisting them in making critical decisions about the education of children with autism. Design, modeling, and visualization approaches were utilized to create digital tools for electronic recording of data from children with ASD and the outcomes of medical, psychological, and educational work. The initiative was created using technologies that allow to accompany children with ASD more effectively. The digital platform was created with WordPress. A content management system was that allows administrators to control the site's structure through a customized administration interface. All project participants' data is stored in cloud systems together with the outcomes of medical, psychological, and educational activities. Templates for personalized child development programs, development tracks, and advice for parents and professionals. The dashboard reflects the visualization of all data. Educators may use visual analytics to create customized kids development programs. Next year, we are planning to develop a mobile version for the online system in order to make projects participants, site participants training more accessible by allowing more families to participate in the education process, including those who live in remote areas of the country and do not have access to full-time education, as well as support professionals and students by providing new opportunities for teaching and learning, including in families where normal education is not available. Parents, children with autism spectrum disorders, educators, and students are participants of the project. Each group has its own role, its own part on the platform. When the first signs of autism are found, these type of tools will allow parents to be tested at a convenient time and to contact specialists in a timely manner to provide qualified assistance to a kid. The online system contains digital educational courses placed on the free Russian Stepik online platform to teach parents, professionals, practitioners, and students planning to work with this category of children, using methods with proven effectiveness. This form of training allows raising the awareness of the project participants, attracting those categories of parents and professionals who do not have the opportunity to receive full-time training. The dashboard shows the visual results of the job in the form of graphs and charts. On one screen, managers, experts, and parents could view all the critical information about the child's unique accomplishments, the success of specialist work, and the efficiency of the execution of correctional and developmental work programs. The mobile version of the online system will allow a larger number of professionals and families of children with ASD to participate in the educational process, particularly those in remote regions of the country. All tools are located in the personal account of educators, parents, and students, allowing not only all experts working with the kid to participate in this program, but also parents at home to continue working with their kids, as well as online viewing of individual child achievements. Working together in an open, unified, worldwide research coordination platform will enable researchers from all over the globe to undertake cooperative research focused at enhancing the quality of education and the length of time children with ASD, with autism, their parents and experts receive lifelong education. The digital platform is represented by individual cases of children, parents, professionals, and researchers in the form of templates to fill out. The developers gave situations involving children additional consideration, including the kid's profile, a report on the dynamics of his growth, and the efficiency of working with him, templates for customized child development programs, and advices for parents and professionals, for practitioners. There are 3 stages of the project's work. In order to achieve the project's goals, an IT team of Kazan Federal University initially chose and upgraded a system for data entry and analysis. The university researchers dealing with the problem of studying autism have developed criteria for the selection of existing diagnostic methods with proven effectiveness. At the second page, and the second stage, diagnostic tools for the online system were developed based on technologies with proven effectiveness. Electronic data entry forms were created, algorithms for analyzing the received data, templates for conclusions and recommendations. The third step is now being executed, during which the online system is being tested in the Kazan Federal University kindergarten for kids with ASD. Dear friends, the represented algorithm for working of the online system allows managers to generate reports on the effectiveness of the correction and education, on the results of the work of each specialist, on the achievements of each child in a short time without the involvement of specialists. The digital platform for collecting and visualizing data in accompanying children with autism spectrum disorders includes 6 sections, which provides information about the project, information for parents, information for researchers, volunteers, and philanthropists. Separately, 6 sections are presented with information about the history and current state of knowledge of autism spectrum disorders and comorbid disorders, about ongoing social projects supported at the state level, about scientific projects supported by Kazan Federal University and the project partners. The system's use in the educational sector will hasten the retrieval of knowledge and strategies for dealing with children with ASD, as well as make it possible so swiftly gather statistical data, visualize the result of activities, improve the efficiency of kids' socialization, draw public attention to the problem of autistic disorders. An analysis of the educational market showed that there are competitors, of course, who are narrowly focused. unfortunately, or they offer to buy printed versions of methods. So our project covers a wider range of users and aims to solve different problems using digital format. Dear listeners, dear colleagues, the advantages of the digital platforms are as follows. First of all, technical effect. The proposed project makes it possible to achieve a new technical result for each child with autism, create an electronic case with the results of his examinations carried out by specialists, clarify
Sorry
his
for the
diagnosis.
interruption. You have only 2 minutes left. 3 minutes. Sir.
Excuse me?
Yes, sir. You have only 3 minutes for conclude your presentation, sir.
Okay. 3 minutes more. Okay. Educational effect. The created digital platform makes it possible to collect data not only within the framework of one technology, but also to apply medical, psychological, and pedagogical methods for diagnosing and correcting disorders. It's obvious that we have scientific effect. We'll have scientific effect. It will. It means. It will increase the efficiency of the research process due to a detailed and in-depth analysis of the information received and work with the necessary parameters. Economic effect, I hope using the automatic reporting functions based on artificial intelligence technology, specialists, practitioners will be able to quickly implement collecting data through the report configurator. It will save up to 80% of working time, I hope. And the last one, sustainability of results and impact will be ensured through the following measures. Development of the mobile version of the digital platform, which will attract more professionals and families raising children with ASD, with autism, including those located in remote parts of the country, for the development of digital educational courses and video library that includes video lectures by world-class researchers. That's all I had to say, dear friends. Thank you for your attention.
Thank you so much for your kind presentation.
I think Milan Tuba is there.
Yes. Have you any questions with this?
If you don't have any question, then you can go for the second.
Okay, sir. So our next presenter is Janet, and she will going to present her paper, Explainable Recommender System from Theory to Practice.
Good morning. Please let me share the screen.
And sorry for the interruption. I would like to introduce to all one more our session chair, Professor Kirti.
Okay.
Hello, ma'am. I welcome you in technical session course C.
Yes, thank you, ma'am.
Yes, she is an associate professor in Department of Computer Engineering in Vishwakarma Institute of Information Technology, and she published 20 plus papers in national and international journals. So I welcome you, ma'am. Please start your
Thank you.
presentation.
Yes.
Okay. Good morning to everyone. My name is Janet Chicaiza. I am a professor at Universidad Técnica Particular de Loja of Ecuador. In this moment, I will present a research about explainable recommender systems from theory to practice. This presentation has three main parts, as we can see. First, I will present the background underlying this research to understand The motivation of this research, I will explain the context first. As we know, the recommender systems supports users' decision making. They are a key for helping users discover resource of relevant items in an information overload ecosystem like the web. Like other artificial intelligence-based applications, these systems suffer from the problem of lack interpretability and explanation of their results. It means that in some cases, recommender systems can be seen like black box models. Enriching the system output with explanations increase the user trustness and reliability regarding the system decisions. Why the systems were selected before delivering to a particular resource as a part of explainability systems. In the accepted paper for this conference, you can find research related to explainable recommender systems and a demonstrative case based on the TripAdvisor data set. Regarding the problem, we considered that making decisions based on models created automatically without understanding how data were transformed into information or knowledge by machines can impact on service users and providers. The solution is to develop explainable systems which can provide explanations not only about the algorithm or decision process, but also about the outputs. Explanations can clarify why specific items are recommended to users. Several approaches have been developed to allow users to understand why a certain recommendation is made. To provide useful explanations for recommender systems output, one option is to use interpretable models. Another research direction on explainability is to take into account external data to generate explanations. Therefore, there are two research directions of recommender systems explainability. The one is model intrinsic and the another is model agnostic approach. The first approach, it tries to develop interpretable models whose decision mechanism is transparent. Thus, we can naturally provide explanations for the model decisions. On the other hand, the model agnostic approach focus on the explainability on the recommendation output. Such models allow the decision mechanism to be a black box and explanations are generated after a decision has been made. These are the two main types or explainable recommender systems. After I can explain two cases in which we try to generate explainable during a recommendation task. To illustrate how explainable recommendation can be generated, we present two cases based on the TripAdvisor dataset. The original dataset described more than 1 million restaurants located in European countries. We select a subset of restaurants to generate explainable recommendation considering the profile of two specific users. Regarding the data preparation from the TripAdvisor dataset, we filtered those European restaurants that offer only Latin American cuisine. Considering this condition, we found that more than 70,000 restaurants and more than 40 features of restaurants. To generate recommendations, we use two different models: the item-based collaborative filter and the knowledge-based node similarity algorithm. To recommend restaurants using the first method, data was structured as a matrix. where and was processed by the collaborative filtering method. For the second method, we create a labeled property graph to organize metadata of restaurants as entities and relationships by using the Neo4j platform. For the first case, the assumption was the target user is interested in visiting well-rated restaurants located in a specific place. In this case, the location was more like located in France. Here, we select a traditional item-based collaborative filter method to generate the top 3 lists of restaurants. And to generate the explanations, we use a item-based approach to enrich the recommended restaurant list with explanations. To guide the decision of the targeted user, we recommend the restaurants because they are similar to other restaurants that the user has liked in the past and that have been similarly rated in some service such as food, service, and value. The recommended restaurants have a high similarity person score with the target restaurant. In the figure, in the upper position, show the main relationships of the target, the restaurant with other entities. And in the lower position of the figure, the relevant features of each recommended restaurant are shown. In the recommendation list, key information about restaurants is presented, as we can see, the name, the city, cuisine, food service value, and atmosphere. For the evaluation of the explanation, we use, for this case, the fidelity measure. We consider as explainable items that are recommended and contain all the attributes used to explain the recommendation. Therefore, applying the equation for fidelity, we obtained about 0.7. This means that a high fidelity recommendation is being provided for this method, or this case, sorry. In the second case, the target user is interested in visiting restaurant that match specific features. To generate recommendations and the underlying explication advisor data set as in this task. As to the previous one, it means the target user is interested in visiting restaurants located in a specific place, for this case, Madrid in Spain. Unlike the previous case, the user has more specific requirements that the recommended restaurants should be matched, such as a specific cuisine and average rating. For this case, the selection of a graph is suitable because it can be traversed using specific and can be filtering according to shows located, highlighting the price range of each one. Thus, interactively, the user could select a specific value for this feature of the price and could receive a more personalized list of items. For this second case, we try to demonstrate how the reasoning is made behind the recommendation mechanism. As we can see in the figure, when a user selects a restaurant, a pop-up window appear showing the main features of the restaurant. And we use a full and short textual as the explanation for the recommendation. As we can see, we highlight the high similarity, what are the features that match with the previous liked restaurant in the past liked by the use. Finally, please let me refer to the conclusion. In this research, we have presented explanations as an important attribute that providers showed to their recommendation service, enrich the recommendation output with explanation can help users understand why an item was given as a recommendation and how it may match or not with their preference. We present the foundation of explainable recommendations. From the theory, we have presented two application scenarios for restaurant recommendation. As we have seen, it has been possible to provide personalized and simple explanations to users depending of their preference, highlighting the key features of the recommended restaurants that could better fit the feature preferred by each user. As future work, we plan to extend the data set with user preference and feedback to evaluate the quality of explanations using other qualitative and quantitative measure. And it's all. Thank you. And if you have questions, I am pending. Thank you.
Yeah, thank you, Janet, for your kind presentation. And please come up with, I would request to one session chair, please come up with the question if you have. Okay.
Hello,
Yes, ma'am.
am I audible?
Yes.
Yeah. So yeah, it is altogether a good presentation that we have seen that almost you have went till the results and the conclusion. And the question that had in mind that you are covered in the conclusion itself, like you will be working further on the particular choice or the choices given by the customers. So that was the question that I was having throughout the session, but in conclusion slide, you have covered that, and I found that this is altogether a good presentation. And I would like to appreciate the effort that you have put. So that is from my side. Thank you, ma'am.
Yes. Thank you, ma'am, for your valuable information. Yes. So our next presenter is Amit Kumar Trivedi, and paper title is On Accountable and Distributed Audit of Outsourced Data.
Hello,
Yes, sir.
is my presentation visible?
Yes, sir. It is visible.
So,
You can
okay.
start. Yes.
Okay, the topic of my presentation is on accountable and distributed audit of outsourced data. And I am Amit Kumar Dwivedi. I am a research scholar in IIIT Vadodara. And Dr. Naveen Kumar is my supervisor, and Manik Lal Das sir is the third author of this paper. So this is the overview of my presentation where I am covering the considered data outsourcing scenario. And then I will motivate why accountability is required. And then I will classify the existing accountability into weak and strong accountability. Then I will further go to strong accountability portion, and then the users like readers, writers, and cloud service providers accountability will be given. And then the comparison of the proposed scheme is done with the existing scheme, and at the end, the experimental evaluation followed by the conclusion. So this is the considered data outsourcing scenario. Here, the three parties are there. One is data owner, another is cloud service provider, and the one is third end users. So data owner actually outsources its data to cloud service provider for availability purposes and for the cost-effective storage as well. And from the cloud service provider, the users are directly accessing the data after getting the access credential from the data owner. So once they get access credential from the data owner, they directly access from the data from the CSP, and they can perform any kind of read-write operation directly to the CSP. So now the assumption is malicious but cautious CSP. It means that this is the public cloud, so the CSP cannot be completely trusted, and it may unauthorizedly modify the data. So, and the second is partially trusted users. The users sometimes ignore the task assigned by the data owner. So as it is the owner of the organization, so sometimes the user may ignore the task assigned by since users are partially registered. So we come to the accountability. What is accountability? It ensures answerability of the participating parties, and it also improves the trust level of data owner on other parties. So we classify accountability into weak and strong. Like weak accountability only ensures the detection of the correct execution of the assigned work. Like whomsoever the auditor is, it can only detect that what mishappening happens. So about the mishappenings, it cannot do anything else. So auditability is a weak form of accountability where we can only detect that whatever happens. So auditing is a posterior mechanism of outsourced data integrity verification. It is a posterior because it only happens once the data is outsourced at the cloud service provider. So it is considered at two types: centralized and distributed. So where the centralized, either data owner or third-party auditor audits the data, and in distributed scheme, the uh, end users, after getting access credentials from the data owner, end users directly audit the data upon read. And proof type, in centralized, in some schemes there are probabilistic, and in some schemes there are deterministic proofs are there. And but in distributed, each data is accessed with and audited with equal probability. Therefore, it is a deterministic scheme. And computation cost at data owner is high because in centralized scheme, it is done in centralized manner. Therefore, the auditor is very much involved in auditing. So that's why the computation cost at data owner is high. And distributed, the auditing job is distributed among the read authorized end users. That is why if only one user, only, a user only audits its own authorized set of data files. So centralized scheme is not a fault tolerant because uh, uh, once a auditor fails, there is no other way to audit the data. But in distributed, if one reader fails, the data can be audited by other users. And the dynamic data supports, it's in some schemes it is there in the centralized scheme, but in distributed it is there at the data is audited and uh, righted by the other users simultaneously. So uh, here come to the strong accountability. So what is the limitation of distributed auditing? That the readers may ignore integrity verification due to efficiency reasons. And it is also there that integrity violating entity is not detectable because we can only detect that there is a violation, but we cannot detect that who is the violator. So writer may upload incorrect data at the server. That writer sometimes may upload false data. So what we can do, we can go for strong accountability that ensures probable detection. That whomsoever the culprit is, we can able to find out that who is the culprit. It can be ensured using digital signature because once the thing is signed by something, then no one can deny whomsoever is signed something. So it also ensures non-repudiation, as we know that once someone has signed some document, then it cannot deny further. So, what are the accountable entities, and what is their accountability? So, the writer is accountable for their uploaded data content, that it cannot deny if there is a fake data uploaded at the CSP. And it also accountable for record structure computation, that it cannot deny the incorrect record structure is found. CSP is accountable for allowing unauthorized modification of the outsourced data. It cannot deny its involvement if any unauthorized modification happens. An auditor is accountable for sending failure report to the data owner at a time, that it cannot deny their role if their failure reports are not communicated to the data owner or delayed. So the scheme is in this scheme, the end users or the auditors directly download the data, verify the integrity of the data record, and if integrity fails, they construct audit report and stores it. And they also sends a failure report to the data owner. So here we can see there are two things, WSH and CSH, and we can see the structure of it. It contains the signature of the writer, and it also contains the signature of the CSP. And for the accountability, owner downloads the data access log file that contains the auditor ID, the data record ID, data record version. RW means the whether the operation is read or write, and this is the time of data write. So on the basis of the data access log, the data owner identifies that whomsoever the um, auditors who have read the same version of data record from the data access log and has not sent the audit has not reported the integrity failure to the data owner, and then using the audit it also asks for the audit report stored at the data at the end user, and using that audit report and failure report and the log record, it verifies the auditor's accountability. So the structure of the failure report, you can say that it contains writer signed proof, CSP signed proof, and everything. This whole data is completely signed by the auditor. You represents the auditor. So this the structure of audit report contains the record ID, data record version, current times, data record write timestamp, and the CSV sign. So if we compare the accountable scheme with the existing other generic scheme that is classified in our earlier work, so we can see that the computation cost at data owner increases with respect to other schemes. But the thing is, this is the only scheme, as to the best of our knowledge, that considers the accountability as a requirement, and since the data owner is verifying the accountability, that is why the computation cost at the data owner is increasing. And subsequently, we can see that the computation cost at the CSP and communication cost between the CSP and the data owner is nil, whereas in other scheme you can see that there is a communication cost involved between the CSP and the data owner. So as compared to previous existing distributed scheme, there is the cost of communication cost between end user and data owner is same, because these all scheme here, if the end users are involved in PBA scheme and existing DS and accountable DS, there are end users, whereas in these four schemes there are only two parties, data owner and CSP. So that is why this cost is heavy. It looks heavy there. And storage at the auditor, we can see there is a higher storage, but this storage will be the only for that particular period when till the new version of data record is not created. So
Sir, you have only 2 minutes for your conclusion presentation.
okay, thank you, ma'am. So if we see the experimental evaluation, so we have experimentally evaluated the computation cost at the data owner, so and the end users. So since data owners the failure report, data owner verifies the failure report, so and the users are actually verifying the integrity failures. So we can see both the diagrams, and the experiments are performed on the three machines. One machine acts as the end user, and second machine act as a data owner, and Ubuntu instance on the AWS works as the CSP. So we can see that computation cost of the auditor of the data owner is proportional to number of failure report and as well as the size of the data file. So if we see the auditor's accountability verification code that I have explained using the log file, so it is also vary as per the number of faulty auditors and as per the size of the log file. So the conclusion is accountability enhances the trust of the data owner, as all parties would be accountable for their doing, and communication cost between end users and DO depends on number of FRs. That, like, if there will be less number of failures, there will be less number of less communication costs. So less frequently accessed data files are verified less frequently, because if there is a file which will be more access, it will be verified more frequently, and if some file will be accessed very less, then it will be verified very less. So that is my conclusion, and thank you very much. Any question?
Sir, I have a question. How the end user will take a corrective action? Like once he has detected that it is the thing. So how the corrective action will be taken place? Can you
No,
tell us?
the corrective action will be taken by the data owner. End user will construct something and report to the data owner. So the corrective action or whatever the action is required will be taken by the data owner.
Okay. Thank you, sir.
Thank you for your kind presentation, sir.
Okay, thank you.
So we are moving our next presenter, Angela, and her paper title is an ICT-based decision support system for the safety transport to dangerous goods along with the Liguria and Tuscany Mediterranean coast.
Okay, good morning, everybody. I try to share my screen
Yes,
with you. Okay. It's good morning or good night. I don't know. And first of all, I thanks to the Intelligent Sustainable System teams. Thanks to Springer, editors and reviewers for this opportunity of publication. This paper regarding an ICT-based decision support system for the safety transport of dangerous goods along the Liguria and Tuscany Mediterranean coast. And this is the results of the work done by a group of researchers. First of all, Abdelatif Sussi, the corresponding author, Professor Roberto Sacile and Enrico Zero of the University of Genoa, Polytechnic School, Department of Informatics, Robotics, Bioengineering, and Engineering System, where I work, and I was a PhD postdoc researcher in supporting smart initiative and trends, sustainable action for people, infrastructure and environment, and enforce security, improving research. The paper starts from the work done during an European project. I go on with the slides. An Interreg Maritime Program Italy-France project concerning the logistic and security in the transport of dangerous goods, where the University of Genoa, my research group, use its competence and skills for the development of systems able to help institutions, public and private ones, to prevent accidents and enforce security in the transport of dangerous goods. In this framework, the European project implement an ICT tool and system configured as a set of joint actions aimed at defining information system, technologies, and training that concern both the monitoring, transport processes, and handling of dangerous goods, as well as a response protocol for emergency management. Then, the importance of the use of tools can be to monitor in real time the risk associated with the land transport of dangerous goods in marine areas near the coast and in port, and mitigate the likelihood of accident and consequences on the territory. In addition, it will increase the safety and improve the risk management of land transports and logistics of dangerous goods in and out of ports, which will protect and enhance the natural, cultural, and human resources located into the cooperation area of this project. In other words, the project and this paper concern the realization of a WebGIS platform representing a decision support system for territorial governance in case of an accident, and aims to increase the level of knowledge on an importance of monitoring and control of the transport of dangerous goods in terms of risk prevention and public safety and interregional level, specifically between Italy and France, because this is the framework of this work. I started now to go into the reason why WebGIS is identified and the importance of the use of the ICT tool in this study. And then I conclude this presentation with the challenge to address. In these pictures, you can see the technology, the equipment that are being installed and used in the project area for the common security system at the Mediterranean level. You can see a drone. In fact, the system has been enhanced by the integration of technologies and equipment, such as drones, for example, which can be used for monitoring traffic and risk situation in real time. So we consider observed data in case of road accident involving dangerous goods. It can be adopted for acquiring images of the event and monitoring and evaluating the consequences to manage the response phase of emergency, the medical services and fire brigades. So all these data collected by the equipment are shared with the operators at the local level, such as policemen, such as firemen, brigades, and so on. To go on, the data are collecting using real system and observed data, and in this collection of images you can imagine the work done to planning the framework of the WebGIS architecture, collect data, install technology, and all the data derived from this kind of technology on the territory come into a WebGIS platform. This is a picture of the coast of Liguria region, in which today I can try to explain three particular functions of our WebGIS platform. The first one, that is called A function or service, is the function of monitoring traffic of dangerous goods go through the land road network. The second one, defined as B function, is the monitoring data of dangerous goods derived from container from the port to the urban area, that come from port to urban area. And the third one and the final one, the C service, is related to the definition of an accident scenario. So the data collection is represented not only using WebGIS coordination and LON-LAT information, but also producing statistics. So click 2 times on this link, I can generate a table. In this table is linked on a cameras installed in the territory that I showed before using photo. And this table describe in the first column the type of the code of dangerous goods material detect. The second column is the proper name of the material in the language of the operators. In this case is an Italian. The third column is the number of transit per type of material detected. And this number is the cumulative number starting from the date of the installation and the date at which the system is open and collecting data. In other words, February 2001. This kind of data are also linked to other kind of statistics, for example, the transit per gate or the mean average of number of transit per hour. For example, at 2 p.m. in the afternoon, 119 trucks transporting silane was detected. Then, to go on, all these data on the WebGIS are related to statistics that are managed by operators at local levels. For example, the policeman of the municipality of Genoa, or in Livorno, that is in Tuscany region, that detect and manage the data derived from dangerous goods transportation in this territory in Tuscany region. Today, I have a screenshot of data available at the keynote speaker time, in which we can see the cumulative number of type of goods transported and detected along the common monitoring system of the area of the project, in which we have 48,678 number of transit in the area of Genoa. That is the cumulative number, that is the sum of all the cumulative gates transit, okay? And for each line, you have an information related to the hazard, the ADR code of a dangerous goods, the name, and the number of transit. So,
Ma'am, you have only 2 minutes left for concluding.
okay, thank you. So this information can be matched with the information at the global scale, and this is a way things that we have to do in the future. So to match the local data with the global database about hazardous material. Then the data can be shown and managed starting from the data derived from port, as I described before for the land part. And we develop other kind of statistic useful for the decision maker, and data can be used not only for the PSA Global Genoa Terminal use, but also for territorial governance use. The third and the last part of this WebGIS platform is related to the identification of hazard, the exposed elements, and the risks perception, using an approach derived from the technological risk assessment. So we define a framework, a flow chart to simplify the shortcut methodology, that is the methodologies to identify the area and the distances of sure impact and the distance of the damage impact. And then we visualize and use this information in order to share this with the other operator in the territorial area involved. Finally, we can use a multi-criteria analysis to highlight, for example, the number of inhabitants involved in a possible scenario of chloride dispersion on air, and the number of schools involved in this possible scenario. So, to conclude, the proposed consequence model based on the shortcut methods allows for determining the impact areas in case of an accident involving dangerous goods. This model provides visualization of the possible outcomes of an event by drawing the impact areas for different accident scenarios, which can provide quick maps of the hazard near the selected areas. This can help decision maker properly to monitor and evaluate the consequences, to plan prevention plans and manage the response phase. Then the model currently has a limited ability to simulate incident scenarios for all dangerous goods transported in the project area. Therefore, the possibility of integrating other tools will be explored as part of the future improvement to medallion system. So that's all. I thank you for your attention, and I'm here for any question or problems. Thank you.
Thank you, ma'am, for your kind presentation. Any question, ma'am?
Yeah, no question from my side.
Yes, no. Thank you. So we are moving to our next presenter, S. Raj Prakash, and paper title is the security algorithm ESBR 2020-22001 used to secure the health data. So S. Raj Prakash is present or not? She is absent. We are moving on next presenter. Our next presenter is Aziz Derman, and paper title is Digital Service Quality from Elderly Generation Perspective Business and Economy in a Theoretical Framework.
Thank you. Can you hear me?
Yes, sir.
Ready? Yeah, I share the screen now.
Yeah.
Okay. Hi everyone. Today I would like to present a little part of our initial research. I mean the idea of this work actually in response with the way the use of ICT during the pandemic. You see, so this is our title today, to a digital service quality from elderly generation perspective to improve online business and economy. So what we propose is a theoretical framework whereby after that we can do further research to get the real result. So the digital service, we refer to anything that related to the services that we get through electronic form, yeah, through the ICT. And then we see during the COVID-19, the pandemic, actually all these services become more serious to us actually. That especially when we cannot go around physically, So then all the communication and in fact all the services now become more critical to people from the to all level of generation. So our focus actually to the elderly people. So one question actually raised from this or emerged from this situation in our software community, in fact in our group as well. So that we ask how can we produce a product, a software product that meet the needs of these elderly. They have little knowledge of computer, in fact little knowledge of the technology. So in fact this is also true even before the pandemic. So just some short statistic from UK, for example, 76% of them in 2019, these elderly people had used all the internet services for the past 3 months during that survey. And out of that, almost 61%, more than half use the internet daily. So they actually part of the community that use all the internet services or the digital services. Yeah. Then in Malaysia, actually during the implementation of the MCO, I very much remember on that, on the 18th of March 2020. The thing here, the business style, the approach actually already changed. Yeah, people start looking into the internet, especially through the door delivery system and all that. So you order the thing, the product you want through the internet. But then again, there's a lot of complaint also reported in terms of the usability of the product, especially when we pass down to the senior people. They want to order something, use the system. So this is they need more assistance from their friends and all that. So the presence. So we conclude that the presence of these older people in the design and evaluation of the software application very much needed. Yeah, so that we also address their requirement. As a background study, actually, most of us, when we design the software, we always focus on the user. User means everybody that normal people. If we deal with the disabled people, then we design with the disabled people. But these elderly, are they disabled or they just normal people? That's the issue. So we have to actually to consider. They are not disabled, but there are a lot of shortcomings on them. Probably they cannot read very fast. You know, they need a bigger size of font of that kind. So that's the idea that need to be addressed during the design and also the implementation of that software. So we see this gap actually demonstrate the needs for business and software engineers also to better understand kinds of user behavior, these elderly people. What are their interests, you know, how they interact with the system. Is it very fast, very slow? The color probably very much different probably from the normal people. So this is again bring us to the understanding of age-related ability and access to e-commerce may be very important to be considered during the design and the development of the software. So the elderly generation, I'm talking about in Malaysia. For now, we have around 10-12% of the population is the elderly. But again, based on the United Nations projection, by 2030, our population, our age population will be reached 15%. Then at the time, then we can be considered as an older country. So with this number, big number, we need to actually to address seriously the kind of digital services that can be provided to them, so that they are part of the consideration during whoever the service provider want to provide the service, but address their needs. So here actually we review the importance of even ICT to the order, and we need some all the devices should compatible with their needs, skill, and also the acceptance of them. So the framework actually we try to address the issue. We identify we should identify the current practice on software usage among the citizen, the older citizens, and finally we should propose the design that dedicated to a particular application and also to a particular target customer. If they are targeted to the older people, then heavy consideration, yeah, very strict consideration should be addressed to them. Okay, for this theoretical framework, we should consider various product quality model, so we can choose the available quality model based on ISO 9126 or even the latest ISO 25010. So we can choose what kind of what sort of parameter that need to be addressed in accordance to the need of these older people. Yeah, and also we need to consider also the assessment. Yeah, most of the time we should consider the assessment part of the process in the framework. Yeah, so that what we call it, the approach is not rigid, but it's based on the needs. Maybe it might change depending on the application but itself. Yeah. For that also, we also propose the 4 approach to this framework. During the conceptual design, digital service impact should be reviewed and updated. We should examine the existing issues and challenges among the older or senior citizen. And this is yeah, again 2 minutes. Okay. And phase 2, we should do the empirical study to get the real needs from the elderly generation. If we do it in Malaysia, then we should go for Malaysian and also non-Malaysian citizen in the country. Respondent should be the older one. Okay. The third one, we should during the model development, we should bring all the expectation from the elderly into the system. And number 4, of course, the validation. We can do it through prototype. Here I want to show probably this is the research flow chart, but the most important one is the framework I want to show you here. This is a kind of framework that we need to consider during the development of software application. We should identify the product quality model that we want to use. We should address the assessment issue so that what we get from the product later on, actually that what we expect to, and we should address all the generation, especially the elderly generation. And for elderly generation, we have to bring out all the issues, the common issue to them, so they are happy, they are interested to use the application, and that will bring the good thing in the community. So this is the framework. So we can always adopt this framework to our own application if we want to develop something. So this is what we call the OP SQ model. That is the name. So this framework actually we try to highlight the component, but we have to do a bit more research to get the detail of those components. We have to find the older people, the representation of them before we develop the software. And then I'm sure if we manage to develop this model, we can increase the knowledge in the software engineering research and the community, so that we can contribute more to the society. Okay, so a simple conclusion from here. So we just provide a framework at the moment. We are looking more on to get some funding from extra funding to go into the real empirical study and to get the detailed model in place. Inshallah, we will do that probably by next year. I think that's all from me for today. And thank you all. I can answer the question if we have one or two.
Yes.
All right.
Yes.
Then no question. Thank you very much.
Yes. Thank you so much.
Right.
So all the presentations are done. So I sincerely thank our all authors for their great presentation and contribution to this session, and all our participants for being a part of this world conference. I hope this session was informative enough to all. We, on behalf of the whole team, thank you so much for support in this version and previous 5th version. We will happy to have you in the 8th version of this conference. So all the presenters would be getting their digital certificates through the mail within a 2 or 3 working days. Further, all the papers already forwarded to the Swinger publication and will be live within a 5 to 6 months. So please kindly cooperate with the team of WS4 2020. And I also thank our session chair, Professor Durgesh Kumar Mishra, Milind Chuba sir, and Dr. Kirti ma'am. Here is the token of appreciation, sir, for sharing the session. Durgesh Kumar sir and Professor Milan Chuba sir and the Kirti ma'am. Thank you so much for your valuable presence and kind information to all authors.
Thank you, thank you, thank you.
Yes, sir. So at the end of the session, request to all, please turn on your camera for a quick snapshot of this virtual conference. Yeah. So 3, 2, 1, yes. Stay safe, take care.
Thank you, thank you.
Thank you, ma'am.
Thank you all of you.
Thank you.
Thank you. Bye.
Bye.